Hello everyone, I'm Yogesh Panchal, faculty of the subject Engineering Graphics and Design. Today I want to discuss about chapter Orthographic Projections and Sectional Orthographic Projections, in which today we will focus on Sectional Orthographic Projections. Now, why Sectional Orthographic Projections are used? To understand inner details of complex object. Sometimes object is very complicated from inner sides. So in orthographic projections, we will see there are number of lines, projection lines, hidden lines, outer lines, but we cannot understand from the inner part of the object. So to clearly understand what is the internal shapes, we must know the sectional views of particular objects like sectional front view, sectional side view, or sectional top view. So that's why we are using sectional orthographic projections. Now, types of sectional views. So first, full section. You can see here there is one flange. It is cut by a cutting plane, and the cutting plane is passing through the object from top to bottom. So this type of section is known as full sections. So here you can see the front view of this particular object from here. This is our front view, which is known as sectional front view, which indicates the green surface which are undercutting. So that surface is represented by section line or hatching lines. Second is half section. So when we cut the object in such a way that the cutting plane is cut the object like this portion and this portion means the cutting plane is perpendicular 1 and 2. So when we remove this part, means the quarter part of the flange, then when we observe front view, then only the half front view are undercutting. So this part is represented by hatching line. This is known as half section. Now partial section means if we remove the some part of the object and then we are focusing on the sectional view of that particular part, then this type of sectional is known as partial selection. This type of section is known as partial section. Now another offset section. So if the cutting plane is not in particular one plane, but it is passing from some required holes like this, and the cutting plane is in zigzag manner, or you can say offset, then this type of section is known as offset section. Here you can see the front view of this object after removing the half portions, which is observed side. When we remove this part, the back side object looks like this, and when we observe the front view, that is known as sectional front view. But this type of section is known as offset section. Here this line is known as section line. This arrow represents we have to cut the object from here and remove this part, and then see the front. Now revolve section. In this object which is tapered from here, the cross section is vary from left to right. So the shape of the cross section is remain same, but the size of the cross section will be reducing. So in this type of sections, we can understand the cross section of the part using revolve sections. So I section is revolve section for this particular part. And last, remove sections. If we remove the cross section from this cutting plane and show the outside by separate section, then this type of section is known as a remove section. Now to cut the object, we are using different types of cutting planes for full sectional views. Actually, we are using only full sectional views. We are not interested in half section, revolve section, remove section in this particular chapter. So we are focusing on only the full sectional views. So to obtain the full sectional views, we are using different types of cutting plane, like a cutting plane parallel to vertical plane, cutting plane parallel to horizontal plane, cutting plane parallel to profile. Now cutting line. So cutting line is represented like chain line. At both the ends are thick, and between the end there is a thin chain line, line dash, line dash, line dash. Cutting plane line is also known as line of section or trace of the cutting plane. Now hatching line or section lines. Whenever you cut the object and if you observe the object and drawn in 2D, the surface which are undercutting is represented by hatching lines. So normally hatching lines or section line are drawn at 45 degree with the reference horizontal line, and the hatching line are evenly spaced at about 2 to 3 apart. So this is the section lines. All the section lines are parallel to each other, and the distance between these two hatch lines is approximately 2 to 3 and hatching lines are inclined at 45 degree with horizontal line. So here the lines are inclined anti-clockwise 45 degree. You can also use clockwise 45 degree also. So keep in your mind whenever you draw the hatching line. Cutting plane parallel to principal vertical plane. Now here when the object is cut by plane parallel to principal vertical plane, then the real or true shape of the section is observed in front view, and section plane will be seen at cutting plane line in top. For example, here I have an object. This is the position for observe. This is one rectangle prism in which there is a rectangle hole centrally. Now if we cut the object with vertical cutting plane and if we remove the front half portions, then the back side half portion looks like this. Now here the cutting plane is passing through this surface, so that surface is highlighted by hatching line. When we draw the orthographic projections using third angle projection method, the front view of this part means the sectional front view is this, in which the surface undercutting is represented by hatching lines, and the top view, because this is not a sectional top view, we want to draw only top view, then we have to draw the full part top view. Okay, but in sectional view always we have to cut the object with particular cutting plane. Now here the cutting plane looks a chain line, line dash, line dash, line dash in top view, while the front view is sectional front. Another cutting plane, when the cutting plane parallel to principal horizontal plane means horizontal cutting plane. So here one cylinder, this is the position for observer, and the cutting plane is cut by horizontal cutting plane, and if we remove the top half portion, the bottom half portion looks like this. So portion between the observer and plane may be removed and section portion will be as shown in figure. Okay. True shape of section portion will be seen in top view. So when you observe the front view of this part, Means for full cylinder, this is front view, two concentric circles. But for sectional top view, after removing the top portions, the top view will be like this, in which these two surfaces come undercutting. So that surface is represented by hatching lines. Now another example for horizontal cutting plane, in which the object is cut by horizontal cutting plane passing from the center of this circle and remove the top portions above the cutting plane. And when we observe the top view and front view, the front view is in which this is front view, this is top. But in top view, if you want to draw the sectional top view, then we have to remove the upper half portions. If you remove the upper part of the cutting plane, and then for the bottom part, if we observe the top view, that is known as sectional top. Now cutting plane parallel to profile. When the object is cut by plane parallel to profile plane, then the real or true shape of the section is observed in side view, and the section plane will be seen as cutting plane line in top view and front. So this is one object, but this is a one cylinder, this is one slot in one rectangle prism, and this is one rib. This is position for observe, front view, top view and side. If you want to draw the sectional side view, then we have to cut the object with profile cutting plane. Now this is front for full object, top view for full object, and right hand side view. This is a sectional side view. For that we have to remove the half portion, observer side, and this is the back portions. So we have to draw the side view of this portion. Now here the cutting plane is passing from this part, which is highlighted by a section line. Now here, now keep in your mind, whenever a rib is cut with the use of cutting plane in sectional view, we cannot use the hatching line for that rib, because rib is one additional part of the object which is used for increase the strength of the object. So in rib we never use the hatching line or section lines. Sectioning rule for machine elements. Sometimes ribs, rivets, waves, shafts, pins, nuts, bolts, washers, keys and cotter. Whenever the cutting plane is passing through above machine element, and if the cutting plane contains the axis of above machine elements, then they are not sections. Okay, so whenever we cut this type of machine elements and if the cutting plane is passing from the axis of that particular part, then in sectional view we are not using the hatching line or section line for that particular part. However, when the cutting plane is cutting element perpendicular to the axis of the above machine elements, section is taken and in projection hatching lines are drawn. If the cutting plane does not include axis, then the elements are hatched. So these are two examples for machine elements like this. Here this is one rivet which fasten two plates. So in sectional view, this rivet looks like this. It is not drawn with hatching lines or section. This is top. Now similar in one coupling to connect the shaft, and when we cut the object with cutting plane, the front view means sectional front view in which this is a shaft, it is not hatched. Okay, thank you very much for watching this.